This is the running test review for running test number 1. Your test is on Friday, 9:30. All right, so the first problem is asking you to classify and order these numbers from least to greatest. We've been doing this for a little while now, so to take care of this one, I would imagine that if you need to, you can convert all of these to decimals and put them in order from least to greatest. So you can use a calculator to do that, but the important thing to remember is that when you go to classify it, you classify the original numbers that were given to you, not the ones you convert to decimals. So, I don't know, I guess because I'm old and I've been doing this forever, I don't really need a calculator for this one. I'm just going to say that the order for these things goes from the most negative all the way up to that decimal. 2 pi is just a little more than 6. And finally, it's a positive 8. So that's my order from least to greatest. Now I'm going to go through and classify them. First thing I look for is any normal number. A normal number is a natural number, so the 8 is a normal number that's natural. None of the other ones are, though. I look for anything with a pi in it. Pi's are irrationals. Takes care of that one. And anything with a hard square root, which I don't see here either, so no more irrationals. I'm looking for any kind of integer or whole number or anything like that. Negative 3 is a regular number except that it's negative. That makes it an integer. And then the other two, decimals, negative, doesn't really matter. If it's not irrational and it's a decimal of any sort, it's a rational number. The rational symbol is cube. For number 2, again, I'm going to try to do this without a calculator. I see negative 5.9. That's definitely the lowest number. All of the other ones are bigger than 0, so 0 is up next. Square root of 6 is a little less than 3, I would imagine. So we're going to go square root of 6 next. And then 3 pi over 2, that's like saying, you know, take pi times 3, that's roughly what, like 9.3 something, 9.4, but then divide it by 2. So now you're down to like maybe 4.5, 4.6. So it's definitely less than 10, and it is greater than square root of 6. Again, you can use a calculator if you want. Just use the original numbers when it comes to classifying and writing your final answer in order. All right, so here we go again. I'm looking for pi's and weird square roots. Those are the irrationals. Anything that's a regular number, that's a natural, that's 10. 0 is sort of a regular number, but it's the only one that isn't a natural. It fits in the whole number category. And then finally, anything else, pretty much, this is a decimal. Decimal that's not irrational is a decimal that's rational. Okay, this time we're on to simplifying some square roots. I told you that you have numbers 3 through 6. They're all the same rule. They're the product rule. The first two, 3 or 4, ask you to take one square root and split it into 2. The second two ask you to take 2 square roots and put it into 1. So it depends on what the problem tells you to do. This one says split it up, so I'm looking for the biggest perfect square that goes into these. You should probably have a whole list of perfect squares across the top of your paper. If you don't, you should do that now. All the way from 1 times 1 all the way up to 12 times 12. In this case, I think you'll find that 25 is the biggest, so I'm going to write it as the square root of 25 times the square root of 3. Because I can do the square root of 25, that is 5, and the square root of 3 comes down. This is my final answer. Same thing with 300, I'm going to split it into 2. The biggest perfect square is 100. I saw a lot of people writing 25 on their paper. It does go into it evenly, but it's not the biggest one, so it's not totally simplified. If you use 100, you'll be okay. Square root of 100 is 10, and I'm left with the square root of 3 here. That is my final answer. Alright, so I saw a lot of people trying to work out number 5 in some longer way by splitting up the square root of 32, and it would work, but it's really the hard way to do it. If you just recognize that it's 2 square roots, and normally the pattern is that they come back into 1, because they're both under the square root symbol, you can just multiply. This is the square root of 64. And that's equal to 8. And the same thing for number 6. Again, 2 square roots. The intention is to put it back to 1. Since they're both under the square root, you can multiply and use square root of 100, and that's equal to 10. The other problems you have here are dealing with fractions, or division of square roots of some sort. So again, the problem leads you as to what it wants you to do. This one, you have a big square root with two numbers underneath of it. Normally that means they want you to put it back as two separate square roots, like this. Which makes it easy because the square root of 144 is 12, and the square root of 64 is 8. And in one final step, I notice 4 goes into both of those, so I'm going to reduce it to get one final answer. So I circle the final answer, but what I really want to see is how you actually got to that final answer. It's important, and a lot of people like to shortcut this step right here, but it's important because if you look at a problem like this and you recognize that it's really two square roots, well, you can get 3 on the bottom, which is good, but you can't do anything with the square root of 7 on the top. So you just have to leave it. You can't split it. You can't do anything else with it. That's the final answer for that one. So you go to number 9. Number 9 is the same thing, except in reverse. See, here you want to take a big one and put it into two separate ones. Now you have two separate ones. It's actually better to put it back together as one big square root. And when you do that, you can actually simplify. 128 over 2 is 64. And so square root of 64 is 8. Same thing for this one. Make it one big square root. 80 over 5. That simplifies to square root of 16. And answers 4. Once again, I want to see those steps as to how you actually got down to the square root of 16 and so on. Okay, this time we're on to rationalizing. Rationalizing is only done when there's nothing else you can do. Look at this one, there's no way you can make this one big square root because this one's not under a square root symbol. And really there's nothing you can do to split up the 5. So it's down to the only possible thing to do is rationalize, which is multiply it by that square root over square root like that. If you follow the logic here, square root of 5 times square root of 5 is square root of 25, which is just 5. In other words, whenever you multiply the two square roots of the same number together, really what you get is the number underneath. So we're going to have something over 5. Now here, we have a regular number and one under square root. Those can't be multiplied together, so really the best you can write is 6 square root of 5 over 5. 6 and 5 don't reduce, which is the final answer. This one, again, we're stuck. Even if we did put it as one big square root, it would be 7 over 6, which we can't simplify anyway. So, again, we're stuck with rationalizing. And when we do that, we get a 6 on the bottom, and these two are under square roots, so those can be multiplied together. We get 42. Now, when you get to this point, you should be weary of the idea that square root of 42 seems like kind of a big number. So you want to check to see if there are any perfect squares that divide evenly into it. I think if you check them, you won't find any, which means that this one is actually done. So even with that bigger square root, that's as good as it gets. I have so many people ask me questions on how to do numbers 13 and 14, and I would say it's the same exact thing as you would do for number 3 or number 4 here. It just so happens that you're doing it twice in the same problem. So I would say look at this problem and notice you're going to have to add eventually, but divide it in half. Right here you have negative 6 times the square root of 50. I'm going to take this negative 6 and I'm going to split up square root of 50, 25, and 2. So what you have is negative 6 times the square root of 25 times the square root of 2. The square root of 25 is 5. So what you really have is negative 6 times 5 and the square root of 2. That's negative 30 square root of 2. And I'm going to do the same thing on this side. I'll bring down this 4, and I'm going to split 32 into 16 and 2. And square root of 16 is 4, so what I really have is 4 times 4 square root of 2. That's positive 16 square root of 2. Now you can see I have something square root of 2 here and square root of 2 here. Now I can finally add them, like it asked me to do in the beginning. I get negative 14 square root of 2. Over here, I have 12 square root of 3, and I'm going to subtract 3 square root of 12. I can't do it because the square roots aren't the same. But this 12 square root of 3 is pretty simplified. That's about as low as it's going to get. But this one I can subtract and say, wait a minute, I got 3 times, well, 4 goes into this. And really, so what I got is 12 square root of 3 minus 3 times 2 square root of 3. In other words, 12 square root of 3 minus 6 square root of 3. My final answer is 6 square root of 3. All right, now we're on to simplifying, combining like terms. I told you on the test that you're going to have this one problem of this stuff, and it's going to be something where you actually have to simplify first and then evaluate it. So in this case, these problems are sort of separate right now, but I'm looking for like terms. So I got an x term here and an x term here. Positive 4 and negative 2, that gives me 2x. And then I got 6y here and 7y here. That's 13y. All done. A little bit more complicated in number 16. I have this negative 4 out here. A lot of people like to forget the negative and just multiply with the 4. You should treat it like these two things are together. So I'm going to leave the 16x here for a second. Now I'm going to do negative 4 times 7y. That's negative 28y. Negative 4 times negative 3x. That's positive 12x. And then I got this plus 25y on the end. So now that I look at that, I got an x term here and another positive here. That's positive 16 and positive 12. That's positive 28x when I put them together. I got negative 28y and positive 25y. I put those two numbers together, I get negative 3y. Those are final answers. This time we have ones that ask you to evaluate. Evaluating isn't much different than any other basic algebra you've been doing for a long time. I've got x equals 5 and y equals 2. So what I'm saying is 5 squared plus 2 times 5 plus 2 squared minus 3 times 5. So I got 25. Now I got 2 squared, that's 4. Notice I did the exponent first. 2 squared is 4, times 5 is 20, times 2 is 40, minus 15. 65 minus 15, the answer to the first one is 50. For this one I have 5 there, 2 here, and 3 times 2 on the bottom. So, we look at this, what do we have on the top? I got 2 to the third power, that's 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. This is 25, I got 25 minus 8. That's 17. 3 times 2 is 6. 17 over 6 doesn't reduce. That's it. All right, your word problem for number 19. I didn't type it all in here for you. I figured you could read it along with the paper. It says an internet search engine company charges fees for advertising links. There is a $5 fee to set up an account and a set charge each time someone clicks the link. Optimus sets up an account with a set charge of 75 cents per click, plus the initial fee. write an expression for the total price after C clicks. So you know right away that we're dealing with a total price. If you want to write it as an equation, you can do that. You can say the total equals, you don't have to, but it works. But you know you had to pay $5 to start it up, and then you're going to pay 75 cents every time they click it. So the $5 is a one-time fee, so I'm just writing the 5 one time, and then I'm going to add 75 cents per click. So I don't know how many clicks there are, so the way I represent it is to say 0.75 C. 0.75 per click. Part B says, okay, that's great. Now all of a sudden, Optimus decides that after he wasn't getting too many buyers at his website, he chooses an increased rate of $1.25 per click. So after 1 month of billing it at 75 cents, now he's going to up the rate to $1.25. Write an expression for that. So basically, you have the same kind of idea. For the first month, this is what happened. So you still paid the $5 startup, and you still paid the 75 cents per click for the first month. The difference is from then on out, now you're going to pay $1.25 per click, and it even tells you, instead of using C, use D. So pay the $5 startup fee, pay 75 cents a click for the first month. After that, I pay $1.25 a click for the rest of it. So part C says, find Optimus's actual cost if he got 50 clicks in the first month and 85 in the second. So let me get a value here. I'm going to do 5 plus 0.75 times 50 for the first month click, and 1.25 times 85 for the second one. This is probably a calculator problem, so go ahead and punch that in really quickly. Okay, all in and into the calculator, I get a total of $148.75. Really, word problems aren't as bad as people make them out to be. It's just, I think, a stress factor that people have trouble dealing with. Because they see a big word problem and think it's going to be really hard. It really isn't. Especially if you think about how you would calculate it if you actually knew how many clicks there were. Like in this part A, if I knew there were 10 clicks, I would just say $5 plus 75 cents times 10. Well, instead of saying times 10, you don't know what it is, so you just write a C instead of a 10. Same rationale. Okay, this time we're moving on to dealing with exponents, simplifying exponent problems. When I look at number 20, I'm looking at a few things here. I see basic multiplication, except I got this exponent out here. That's going to throw another step into this. So you got to deal with this exponent on the far outside first. I'm going to write this over again. Just for a minute, I'm not going to do anything with it. But I am going to do something with this. Negative 2 squared, that's negative 2 times negative 2, that's positive 4. Now we got an exponent to an exponent, that's when we multiply. We get to this step. From here, it's only one step to the answer. Basically, I've got a real simple multiplication problem now. The actual numbers get multiplied. Negative 5 and 4, that's negative 20. And the variables, they got an x term here and an x term here. That's when you add the exponents. So this one is x to the 14 and y to the 25th. That is the final answer. So I got something similar in number 21, except now I'm dealing with some problems that got negative exponents in it. What I like to do right away is get rid of those negative exponents, and in that same step I like to simplify the numbers, if I can. So I got 36 divided by 9. Turns out that's equal to 4. So I got a 4 on the top. Okay, now I'm dealing with this x to the negative 3. It's negative, so it doesn't want to stay there. It wants to go down below. I'm going to write it here. Y to the 5th is positive as it is, so I'm going to leave it where it is on the top. Y to the negative 2nd on the bottom, negative, got to go up to the top to turn it positive. And x to the negative 8, also a negative exponent, needs to go to the top, turn it positive. There we go. I'm going to do a little bit of cleaning up, but I'm basically done. You can see here I still got the 4 on the top. Now I got y to the 5th and y squared. Put them together, you got y to the 7th. I got x to the 8th over x to the 3rd. Well, these three x's right here will cancel out 3 of these and leave you with 5 on the top. So what you really have is an x to the 5th that happens to also be on the top. So it looks like we don't need this fraction line at all. Our final answer is just this. Okay, we're on the square roots. Square roots, I'm sorry, not square roots, how about scientific notation? Scientific notation is actually a really easy form of exponent. Basically what they want is for you to be able to leave it in scientific notation and figure out how to get a scientific notation answer out of it when you multiply. Simplest way to do it, multiply the two numbers and add the exponent. We're doing 7.2 times 3.9. That's 28.08. That might not be too good, but we'll fix it in a second. Times 10, and then I add the exponent to the 11. So all I got to do really is fix this number so that it's between 1 and 10. So I'm going to move the decimal point back one place to make it 2.808 times 10. And since I moved the decimal point to the left, I add to the exponent. Now we got final answer. So the same thing's going to happen in number 23, except we're going to divide. So we divide the regular numbers. That gives me 0.8. Again, not so good. The times 10 here, we just subtract. 5 minus 11, that's negative 6. This time I need to move the decimal point to the right, which makes that 8.0 times 10. And since I move to the right, I subtract 1 from that. Negative 6 minus 1 is negative 7. Final answer. Almost there. All right, the last ones are kind of the fun ones that most people have no trouble with. So I ask you, is this a function or not a function? We actually use this one in class, I think, at some point. Okay, from last name to social security number. So let's say your last name, you're really cool, is Norris. That means if you type in last name, you automatically only get one social security number. So sort of, if you type in Norris, the only social security number you'll get is Chuck Norris's last name and social security number. Doesn't work that way. If you enter in Norris, you might get any number of social security numbers. So I would say if you enter in Norris, you get more than one social security number, which makes this not a function. All right, so if you look at part B and it says, from social security number to last name. Well, now let's say that you enter in Chuck Norris's social security number. If you enter that in, do you get his last name and only his last name? And that answer is yes. Remember, social security number is like an identifying number to one specific person. So if you enter that number, you only get one person's last name. You would only get Norris. That one is a yes. Say it like that. Okay, last and not least, number 25 asks you, is this graph a function? Easiest one on the whole paper. You're looking for a vertical line test. Can I draw a vertical line that would touch this graph more than once? And that answer is absolutely. You draw it right here. You see it touches the graph many times. That's not a function. All right, that's it. That is your test review. Good luck tomorrow.